part 2 of solving linear equations only using addition and subtraction. Let's take a look at some more examples. All right, now we're getting kind of familiar with the ideas. The first step is always to take a look at each side separately and see if you can simplify that. So the left-hand side, okay, if you see parentheses, you can simplify it. So we would write 6 minus 15, okay? And on the right, can we simplify that? Let's take a look at that. Yeah, if there are parentheses, we can simplify it. We would get 5x plus 20. So I'm going to indicate again, that was us step 1, and we're finished because there's nothing more to be done with the left or with the right. So it's time to, now it's time to get all of the variable terms on one side and all of the numeric terms or the constant terms on the other side. So I'm going to draw a line to indicate left and right side of my equation. So let's take a look. We've got a variable term on the left, we've got a variable term on the right, we've got to get them on one side. So we've got to make a decision, left or right, and it doesn't matter. So let's just say, okay, we want to get all of our variable terms on the left, which indicates we automatically know that once you decide you want the variable terms on the left, all of the numbers are going to be on the right. So we've got, who's out of place? Yeah, the 5x is out of place, so we don't want him on the right, we want him to move him, so we are going to, let me get a red pen, decide we want to move that whole term. We are going to subtract 5x because that's going to give us what we want. We will have no more variable terms on the right. But if we do it on the right, we've got to do it on the left, so I'm going to indicate that. The results of subtracting 5x from both sides, well, 6x minus 5x is 1x minus 15 equals, and on the right we just have our 20. So now all of the variable terms are on the left. We're good. But we want our numbers on the right. Who is out of place? The 15. What is being done with that 15? It is being subtracted, so we want to undo that by doing the opposite. So we will add 15. That's the opposite of subtracting 15. And if we do it on the left, we have to do it on the right. So the results of doing that, over on the left, x minus 15 plus 15 is x plus 0, or just x, equals, and 20 plus 15 is 35. And we have solved it. And I will say, as teachers do, the check is left to the students. Okay, so we would put that back in. Every place we see an X, chunka to see if it really works, and I'll tell you that it does. Okay, and before we move on, in these last two steps, what we were doing was step 2, where we were moving whole terms using addition and subtraction to get them on the sides that we have decided we want them on. Okay, let's see. Ooh, I like this problem because it's got parentheses and fractions and so forth. So let's see. Let's first draw our line to distinguish between left and right. Okay, is there anything to be done on the left? So our focus is just on one side at a time. Can we clean that up at all? Yeah, I see we can, because we've got common terms, like terms, 6x minus x, so that would be 5x plus 3/4, and we are done simplifying on that side. There's nothing more to be done. On the right, we have parentheses, so we can distribute that 2 to get 4x minus, and 2 times 1/12 would be, I'll leave that to you if you need to verify, 1/6. So at this point, we have completely cleaned up each side separately. So that was whoa, I didn't mean to do that. That was step 1, what we just did, where we're cleaning up each side separately. So we're ready for step 2, where we start to try to move terms to the opposite sides. And the goal is always to get all of your variable terms on one side and your constant terms or plain old numbers on the other side. So let's take a look at the variable terms first. I see on this side we have a 5x, and on the other side we have a 4x, so we've got to get them on the same side. Doesn't matter left or right, but we've got to make a decision. So I'm just going to decide, well, let's just do it on the left. So this guy is out of place. If we want to get rid of him, we're going to have to add or subtract. So what are we going to have to add or subtract? Yeah, we are going to have to, let's do this in red, subtract 4x. That's going to get him off that right-hand side, but if we do it on the right, we got to do it on the left. And what happened to our little here? Result of that would be 5x minus 4x is 1x plus 3/4, and on the right, 4x minus 4x, that just goes away to 0, so we have equals a negative 1/6. All right, so we got all of our variables on the left. Now we have to worry to get all of our old numbers on the right. Who's out of place? Yeah, 3/4. What's being done with it? It is being added, so we want to do the opposite of that, which is to subtract. So we're going to subtract 3/4 from this side, and the other side just kind of comes along with that. So, okay, if he gets a minus 3/4, I do too. So the result of that, x equals, those cancel. Uh-oh, we've got fractions, and they do not have common denominators. So we know what we're going to have to do, though. We have negative 1/6 minus 3/4, and since you know how to add subtract fractions, I'm going to shut up here for a second. Common denominator, common denominator. Okay. And the result of that would be x. We still have our little x naked and alone on the left, and on the right we have a negative 11/12. One thing I want to point out, do not freak out when you see fractions. You'll think, oh, nothing, I don't know how to do this. If you know how to do it with regular old whole numbers or integers, you know how to do it with fractions. Okay, and the last problem, I think we went a little bit too far. I guess there is no last problem, so we'll just stop here. Ah, there's a problem. Okay, this one has decimals. Like I'm saying, don't freak out. If you know how to do it with integers, you know how to do it with decimals. So I'm going to try to talk less here. Aren't you glad? Cleaning up. Yeah, we can click there. Okay, over here on the left, that 1 in, I wrote 1 in this time to emphasize it. That's just an in, and this guy's out of place, so let's subtract 0.6, subtract 6, and let's clean this up a little. What's left on the left? 1 in or in. What's left on the right? Done.